Next up is a new book around health data. Marcel Salathé is here already, as far as I know, so he'll be put on stage, and please already start sharing your screen. Marcel Salathé is a Swiss digital epidemiologist. He is currently an associate professor at EPFL and director of the Lab of Digital Epidemiology. In the first year of the COVID-19 pandemic, Salathé was the most quoted scientist in the Swiss media, and it's a great honor to have you here, Marcel, and to get to know more about your experience and perspective in the last year in this pandemic relating COVID and research data. Now,
thank you.
I need to invite you to the spotlight. We can't see you yet. One moment. Here you are. Great.
Okay. Can you see this? Can you see the screen now?
Yes, we can see you and the screen and hear you.
Great. Good. Thanks very much, and thanks very much for the invitation. Always a pleasure, of course, to be at Opendata, and yeah, I was asked to speak a bit about health data, and I do want to do that. And I'll say a few words about COVID and the Swiss COVID app, but that's really more sort of a, you know, an intro into the broader topic. Then I make a rather severe cut in terms of topics, and I start talking about food. But there's a particular reason, right? It's all related to data, so no worries. Yeah, so I don't think I have to go through sort of contact tracing and proximity tracing again, but I do want to briefly highlight a central question which came up, you know, in the early days of the COVID pandemic and during a quite intense phase of protocol design, which, you know, went to the highest levels of governments. I mean, you know, top level, and then of course eventually, right, Google and Apple made decisions about which protocol to implement into the operating system, and that's what we now use. And that is actually also related in one way or another to what data should actually be open, or has to be open rather in this case, right? If you remember, contact tracing or proximity tracing with phones, the idea was that phones, you know, are nearby and sort of make through Bluetooth, right, figure out, you know, what other phones are nearby, and then eventually make a record of that, kind of like a logbook, you know, who were you close by, and close by here always driven by you know, the epidemiological conditions. And then eventually, right, and so this was always done in a way that was meant to be extremely privacy preserving, right? You continuously delete the data from the phone, and, you know, you don't collect any other data and so on. And of course, you do everything out in the open. Well, I shouldn't say of course. That was actually a reason for why the Swiss team eventually broke off with other European teams, because there was no willingness to do this in the open, you know, in other parts of the world, but we insisted on that. But the key question came actually, what happens, right, when somebody who has such an app eventually gets sick, right, gets tested positively for COVID? And, you know, up to this moment, we largely agreed on the technicalities, and this is all of a sudden where we started splitting, where there were by and large two models. One I would call the central or centralized model, where the idea is, if now this person A gets sick and they have been in contact with person B, C, and D, well, then what we'll do, right, is we'll share this information that A was with B, C, and D in contact with the central server, you know, government health authorities. And then what the government obviously can do, right, of all the millions of phones that are out there that run the same app, they can now, you know, contact B, C, and D and say, hey, you were in touch with this person, and therefore, right, you should now take a certain type of action. This sounds very efficient, but actually, if you think a little about it, right, this is quite tricky, because now the central server has information that actually someone was in contact with B, C, and D. And over time, right, as more and more of this data comes in, you can derive all kinds of contact network information that can be used for all kinds of purposes. And as history will then have shown later, has been misused for all kinds of purposes for those few countries that eventually stuck to the system, even though it doesn't actually properly work on most Apple devices. But we were then eventually, right, very strongly against that. We proposed a decentralized model or decentral model. So again, right, you start with the same case. You have now this person A has been in touch with B, C, and D, and is now getting sick. What we're sharing actually now is just the information that A is now positive with the central server. Now, of course, the central server now has no information about who it should inform. All it knows is that A has a positive corona test. So what you of course have to do is now you have to broadcast this information that A has a positive corona test. And again, right, A is of course, it's all anonymized, but still, right, you have to broadcast this information to all the devices. That seems inefficient, and admittedly, right, from a bandwidth perspective, it is not as efficient as the other system. But what happens is that now every phone can check locally on its own device, right, whether it has been in touch with A. And B, C, and D, of course, I mean, it's the software, right, that does that in Switzerland. That would be the Swiss COVID app. Then realizes, oh, actually, I have been in touch with A. So B, C, and D's get the alerts. So you can see the exact same outcome happens here, right? But very different. The key difference is what type of data is shared. And that, eventually, it seems like such a technicality, but it eventually, became the crux at, almost, pretty much a prime minister level in Europe and other countries, where the question was, is the fact that A is now has been infected, is that critical data, or is that A had contact with B, C, and D? Is that the critical data? And in Switzerland, right, the group that developed the decentralized models, we very strongly argued that actually the data that should be open, if you will, right, not because we want it to be open, but because it has to be shared, right, with others, should be just the fact that A has been positive, because A has been tested and is in some sense already in the system, and the fact that someone had a positive test is really not quite as privacy concerning as the fact that A was in contact with B, C, and D. And that, right, it eventually became a huge discussion point. But again, in this decentralized model, the decisions are made locally, and there's no central authority who has information about the contact network data. And that, was eventually, right, proposed as decentralized privacy preserving proximity tracing. And it was eventually what also was adopted by Google and Apple. So most countries that now use proximity tracing on their apps use this model, because there's really no other way that you can do it, in particular on an iOS device. And there are a few countries, and in Europe, it's notably only France that went with a centralized model. And that's probably the moment to insert a joke about France and centralization, but I'm not going to do that. But just so that you know that there's one country that did that, and they in Europe, and they did it particularly right on the ground of what piece of data should we send out into the open to be shared with everyone else. So right, in this case, obviously the fact that a piece of data has to be open really became sort of the critical discussion point at an extremely high political level that I have myself never personally sort of lived through, and it was quite an interesting discussion. I also just briefly want to mention this because I occasionally get asked, right, does this actually work? We never hear anything about it. Yes, it does work, right? It's actually highly effective. It's just that in Switzerland, we can't really demonstrate it because the public health system and the medical system around this app did not collect the necessary data. But the Brits, for example, did, and there's now studies coming out also from other countries showing just how efficient this app was. I mean, roughly the idea was that for every percentage of app use, you could avoid roughly 1% of cases. And I leave this as an exercise, right, to the audience, what that would have meant, if 60, 80% of people would have used this app. Now, I said, right, I eventually will switch to food, and this is now the moment where I want to do that, because most of my time, actually, I don't spend on infectious diseases anymore, which I guess, is my problem now that I'm associated with COVID, but that's fine, I can live with that. But actually, right, I spend 90% of my working time now on nutrition, and that's mostly driven by this graph from Our World in Data. And what this graph shows you is that as countries move to the right, from lower GDP, so poorer countries, to higher GDP, richer countries, the share of burden that comes from non-infectious diseases, NCDs, non-communicable diseases, which is in the beginning is very small, eventually grows to be dominant. And that's also, by the way, our history, right? If you think about Switzerland or other, wealthy countries in Europe, for example, it used to be, right, 150 years ago, pretty much all the burden of disease came from infectious diseases. And then, as you get wealthier, that shifts. And now for a country like Switzerland, 90% of the burden of diseases come from non-communicable diseases, right? Cancer, metabolic diseases, heart diseases, you name it. And what's interesting is that if you look a little bit at, what is the source of this, there are obvious causes like, smoking and alcohol and exercise. These are all important causes, but from a perspective of science, I find none of them as interesting as nutrition, because to this day, it's not fully clear, right, what actually healthy nutrition is. It's very clear, right, what a healthy cigarette is, because it doesn't exist. It's very clear in terms of exercise, right, what it means. More exercise, better than less exercise. And with alcohol, same thing. It's a bit of a debate, right, whether one drink a day might be actually on balance good, or at least not bad, but the direction, right? Less alcohol, generally better. With food, it's really quite an open discussion, what kind of food, how much, when, and so on. And so there's this great study, this sort of a Lancet report on food that puts this really succinctly, right, where they say unhealthy diets pose a greater risk to death and diseases, right? So morbidity, mortality, than does unsafe sex, alcohol consumption, drug use, and tobacco use combined, right? And that this is really overwhelming evidence, right, that unhealthy diets explain 1/5 of premature death. That's something, right, to let sink in. And so we are running since a couple of years a so-called digital cohort. I'm not going to go into this, but the reason why I'm mentioning it is actually we had to build a lot of infrastructure to run such a cohort. One of these infrastructure was a project we originally called Open Food, in which I think I also presented once here at an Open Data conference. That still exists. It's just called Food Repo now, but it's still the same thing. And actually we expanded it to 4 different countries, the US, Germany, and Italy. And there's probably more to come. But I want to highlight here this particular case of tracking food during this study. So we had to build also a way for people to easily track their nutrition very accurately, right, over a period of, say, 14 days. How we do this is we built an app and the food tracking system that, on the one hand, connects to this food repo database. That's an open database, right? An open API of barcoded food products in Switzerland, and that's still actively maintained and growing. But it also connects now to an algorithm that recognizes food from an image in case it doesn't come from a barcode. And most time, right, food does not have a barcode associated with it. And it's that what I want to talk about today. And the data that we now see, you know, after having hundreds of thousands of dishes collected in the context of this study and others, is that the vast majority of data comes in as images, not as barcode scans or text information, but simply as images. And so we need machine learning algorithms that can recognize these images, you know, recognize which part is food, recognize what is it, and so on. And then, you know, we verify this by a human annotator. This is now used in a couple of studies, and there's more studies that are using this. And this is what it looks like. It's not so important, but you have an app and you have a sort of system on the back end for professional annotators to look at this data and correct the AI algorithm. So basically, here's how it works, right? So data comes in forms of images. So I call this non-annotated data. So, you know, as a pure data source at this point, it's useless, right, for us. So we need to annotate it. And if we would annotate every image by hand by a human, right, this would take us forever. It's too expensive, takes too long. So we need a machine learning algorithm that does that for us. And then we can, but because, right, we need to, this is at the end, is for us research data. So we need to have extremely high evidence and high trust in the you know, accuracy of this data. We have a human that then verifies the output, and that's our really, right, it's the bandwidth issue for us. And then in the end, right, you have annotated and verified data. There's a catch-22, right? Where does this algorithm come from? How do you build an algorithm that can do that? Well, you know, what you would usually do is you would say, well, okay, let's go and see who has data. And then we build an algorithm. So you go over, right, to Google and say, hey, Google, show me what you have in terms of food images. And Google tells you, hey, here's what I have in terms of food images. And, you know, you believe that this is real food to the extent that you believe Instagram is the real world, right? It's real life. It's you know, you can actually force Google, or I'd say, no, hey, I actually mean regular food, right? I'm going to update my search query here. Even then, right, Google fails to give you actual food. I mean, there's one or two pictures here that look a bit like actual food, but it's just not accurate because people don't upload food images, real food images, to the internet because it's just ugly, right? This is what images look like that we're getting through this app, right? I mean, I'm sure that's all delicious food, and you know, you ate it maybe in the company of friends and so on, and it smelled great, but you know, it's not stock photography. So what we figured is, hey, actually, you know, let's turn this line here into a circle and ask users, and I have this here previously, right? You see this little toggle here in the app that says, hey, would you be willing to share your food images here with the public, right? So we can use it for open data AI training. And it turns out, right, many people do that. Actually, it's now a majority that does that. So what we do here is say, okay, let's do a public benchmark of these algorithms with open data. And then if that works and somebody anywhere in the world, right, takes our data, builds an algorithm that is better than what we have, hey, we're going to use that, right? We're going to deploy that immediately to our API, and we're going to use that in the app. And if that's better, well, then that means, you know, the human verification or correction step, right, takes a little less time, and we can get more data, which should turn into better algorithms, which gets us more data and so on, right? We're in that virtuous cycle. And I've been, you know, hammering this idea in for years and years without having anything to show for it, you know, for a long time. But finally, right, we were able to launch this a bit more than a year ago on a platform that's actually a spin-off from my lab. We call this the Food Recognition Challenge. It ran 4 rounds. We're soon going to announce the 5th one. So basically what happens here, and I guess this is the key slide, is that people come to this platform And then they access open data, right? This open data that we made available thanks to all the participants who turned that toggle to agree to open public data sharing. So they download the annotated data, they train a model, and then they upload their model in the form of code. Now we take their code and we run it and execute it on the data that has not been publicly released, but also been annotated. And we can really accurately test how well is this submitted solution doing. And then we can put that on a leaderboard. And so it gets a bit competitive and people really quite like that. And you can see, right, how accuracies go up and how more and more people participate. And then, right, when you have an algorithm that's better, you can say, okay, goodbye, old algorithm, right? I'm going to use the new algorithm. And nobody really realizes this, except probably the annotators who realize that the algorithms have now gotten much, much better. And so this is my last slide. We just recently, right, did the really intense test of, does that actually work? I mean, the annotators tell us it's night and day difference. But now we also know, right, through measuring that it improved our our annotation time by about 20% just after doing this for about 1 year in the middle of a COVID crisis. And this is quite a significant time saving for us, because it means we can roughly, right, increase our throughput by a fifth or potentially even more. And so we're going to continue this. But I think, right, I should also mention here, these are open algorithms at the end. So everybody who builds their own apps or who uses food recognition can now just go and use these algorithms, because they're all open and they're trained on open data, right? This would not be possible without the release of this open data. And I hope that's a model we see much, much more, right? We talk a lot about this accountability of algorithms and so on. My answer is always, hey, put it on an open platform. I mean, you can use another platform. You don't have to use AI Crowd, but run an open benchmark, right? Nothing beats the transparency of an open machine learning benchmark with open data. And finally, I have demonstrable proof that this actually works. So that's it, right? So I hope this showed a little bit, right? Two very different data in the context of health applications. One where this open data was very clearly seen as a risk, and in the other where the open data is very clearly seen as an opportunity to accelerate the technology development. Good. Thanks very much. Happy to take questions.
Thank you, Marcel. Great transition to the food data world. Mm-hmm. Are there any questions from the audience? Otherwise, I will start. You didn't invest that much time to explain the app with which users can participate and contribute. The app provides a personal benefit to the users, and that's why they use it, I assume, because they can track their own food consumption and improve their nutrition uptake or something like that. But I'm just guessing. What motivates users?
Yeah, no, we're not quite there yet. In our case, the app is used at the moment exclusively by research cohorts. So ourselves, of course, hospitals or other research projects who are studying something, right? Some disease typically, or some biological phenomenon, and they want to understand what is the nutrition, right, of their participants. And so people are motivated already by something else. And then, you ask them to use this app, and the app itself does not have to be intrinsically motivating. But it has to be, of course, it is good if it does that, but it's really mostly the study itself that motivates people to participate. We have, we've seen a lot of these apps, right, where they say, hey, we can help you, please use our app and upload all this data. But this data goes nowhere, right? It's certainly not shared as open data. it's used then as property of those apps, who then use it to train and improve their own algorithms. And then, you know, they really have to work hard to make sure that the use of the app remains attractive. And that's very challenging. And we often see, you know, over promising there of benefits. And we are, you know, fortunate we don't have to do that, because we're always associated with research projects that are already motivating to the participants.
But the app is public, right? So we could all start using it and contribute.
No, well, I mean, you can download the app, but you need a participation code, and without that, you can't really use the app, because, right? Keep in mind, right? Every participant that starts using the app, it's work on our side, because we will have to annotate and verify the data. So at the moment, we hand out these codes on a per cohort basis. It's quite possible that the algorithms are soon getting to a stage where they're so good that we can say, look, if you're willing, right, to live with a bit of uncertainty and error in the data, you can now use the app, and basically, right, the feedback is instantaneous, and we remove the human annotation step. That will probably come at some point next year. But at the moment, it's by invitation only through these research cohorts.
Great, thank you. And two questions from the chat. One is about potential biases. I can imagine that most of the app users are generally people concerned about their diet, and therefore you get more salad pictures than hot dog pictures. So did you notice a recognition accuracy based on the type of food, similar to what happens to now I lost the track, male and non-white face recognition?
Yeah, so yes and no. I mean, on the one hand, in our own study, the food and use study, it is true, right, that we see a slightly, we see an over-educated population in Switzerland that is probably over proportionally at ease with digital tools. Whether that directly, and you know, they're clearly interested in nutrition, it's not clear from the data itself that directly translates into a fantastically different diet. We're still analyzing the data. We hope to have something out before the end of the year. The preliminary analysis shows not a very strong difference to the data that, for example, the MENU-CH study, which is sort of this gold standard food consumption study in Switzerland, has collected. And they have been very careful, right, to make sure they have a representative sample of the Swiss population. It is true that we do get a lot of salad pictures, and even though I love eating salad, I don't like it as an image recognition problem, because it's actually very hard. Of course, you can recognize, right, the salad very easily, but one of the beauties about salads is of course that it can mix and match with all kinds of vegetables, and that always is a super hard challenge for the machine learning algorithm. But we're on that, and I think as soon as we solve that problem, this will be a good day for us. So we don't see a bias, of course, right? You see a strong bias in consumption, but that's normal, right? I mean, if I look at my most frequent foods, you know, it's the usual suspects, and you know, coffee, right? Water, wine, beer, croissants. In my case, pizza. Are things you see relatively commonly. It's a very non-normal distribution when you look at sort of food classes, where for some food classes, right, we have thousands of images, and for others, we barely have a few.
Thank you. Another question about how the app works. What is the output of the food recognition? Is it nutritions in what unit?
Yeah, So what it actually needs to predict is a food class, and that food class then maps to a food list. And depending on which country you're in, that food list will be different, right? So we started in Switzerland, and we used the food list that came from the MENU-CH study. There's an official Swiss food composition database also. We have now, based on the rather extensive experience we now have from this couple of years, we have a slightly modified version because we realized a lot of things were missing in those lists. And we're very happy, of course, to release that openly also. And so that links then to these food classes, and those food classes then themselves, right, are linked to a list of nutrients, and those typically come from the government, right? So the government has a list of macro and micronutrients of a banana. It's clear, right, that not every 2 bananas are identically the same, but every country has a definition of what is the nutritional composition of a banana, and the other, thousands of classes. When you use the system in the US, it tries to predict the class that's correspondingly in the US list. In Germany, it's the German list, and so on. So it will be interesting. We just started this year to work with American collaborators and with German collaborators, and it will actually be interesting to look at the comparison between different countries. But so, right, like this, you can then really have a very detailed photographic evidence of micronutrients in a rather unparalleled high resolution. Clearly, you're going to have uncertainties around that data, right? There's things you don't see, right? Even the best algorithm cannot see whether you added, 7 grams of salt to your pizza dough or 5 grams. But that's not necessarily the goal right now. The goal is just to be much better than the current standards, which are essentially just food frequency questionnaires or 1 day, 24-hour food recalls.
Thank you. We have a lot of questions to cover. Wouldn't be a participation collaboration with databases of recipe websites an option, like complete the picture?
Yeah, absolutely. And whether participants want to annotate pictures themselves, right? So this is a great question. I definitely want to go into that direction, right? Eventually, you want to have an understanding of, compositional foods, because many of the images are, of course, compositional. They're not just, coffee and banana. They're, some plate, right, at home or in a restaurant, which represents a certain recipe. That's definitely the next step we want to go into. At the moment, we don't have that because the food list we use is relatively extensive, but it's an extremely interesting extension. Participants annotating pictures themselves. So this is a very interesting question, right? Because pretty much every other food tracking app you find out there does exactly that, right? You have to insert the data. It's just typically a gloriously beautiful user interface, but essentially it's still just, you are inserting the data. You're giving all the data to that, you're doing all the work, right, for the app. Whereas in our case, we philosophically started with the notion that people don't like to track their food, right? It's something cumbersome. They don't want to do that. So let's make it as easy as possible, right? You take your phone out, snap a picture, you put it back, right? Done. And then we do all the work, mostly by hand and now increasingly by algorithms. And that makes the app a very sort of pleasurable experience, right? It's something that you just quickly use and then you don't think about it. If we have to go to the level where we say, well, could you please annotate some of the data? We would abandon this philosophy a little bit, but we'll eventually probably have to do it, or we can start to do it when the algorithms are accurate enough. In the beginning, when they're not very accurate enough, basically a user would have to correct everything, and users don't like it, right? People don't like it when the app gives them wrong results. If there's an occasional mistake, yeah, you're, I think, more happy to fix it, but we really don't want to make the users work. So we'll do that at the moment on their behalf. Like this, we can also have high trust in the data. And as the algorithms get better, we can maybe bring in more and more people who are willing to live with a certain margin of error.
Adding to the question about bias in types of food, and I feel like the presentations from above, from before, have an impact on the questions now. Have you considered presentation of certain cuisines leading to worse recognition, for example, Indian food or Italian, or are
Absolutely.
you out for this?
Absolutely, it's a classic, right? The less images you have, the worse the recognition is. So there's definitely a bias in there. Now, this is also, right, part of the reason why we have this human verification step, right? Because if there's a complicated food, you know, from another culture that Swiss people eat rarely, well, it's likely not recognized correctly. So then the human kicks in, right, and says, no, right, this is not whatever, this is actually this type of food. So from a user's perspective, the user will see no difference, right? That bias will be completely debiased, if you will, by the human verification step. But that's also, you know, part of the reason why we're excited to now go into other countries, the US in particular, of course, because of the large diversity of foods. And then, you know, we can train a sort of a bigger, more sort of globalized algorithm, if you will, that can then recognize different types of foods more easily. It's all a question of data availability, which is why we're going that open data model.
Another question, similar looking foods can have very different properties. How do you deal with something like meat substitute, for example, and whether the substitute is made out of soy or peas?
Yeah, that's a good question. That's a really interesting challenge, right? There's so much creativity right now in the nutrition space, right? In the food space, where all of a sudden, you know, companies, right, create pastas that look like pasta, but they actually have a completely different compositional basis. That's extremely fascinating. It's also extremely challenging from a recognition perspective, but there's sometimes ways that you can recognize this, but also there we're still, if it's something that's rare, which, yeah, meat substitutes still are, even though, you know, it's getting more and more common. We are increasingly, we are also dependent on a flag by the user in this case. Then eventually, right, the algorithm will learn to discern if there's anything discernible from a visual perspective. Then there's also ways, of course, for us, I mean, this is also why the barcoded database is still quite important, because people sometimes indicate or rather scan the barcode of the original package. And of course, in this case, we have the detailed information about it. But it is a challenge. It will continue to be an even bigger challenge. For as long as there's even a slight visual difference, I think we'll be able to handle it. Eventually, if it's completely undistinguishable, it will become undistinguishable also for the algorithm. In this case, we will continue to depend on the user's information about, you know, their types of diet.